Hello everyone, welcome to my channel. So in this video, we will continue our introduction of something in statistics. So in last video, we already give the definition of what is a point estimation and also some important terminology of statistic inference. So in these videos, I want to give more properties or the general concepts of the point estimation. So the first thing I want to talk about is the unbiased estimation. So unbiased estimation is a very important, or unbiased estimator is a very important terminology in the point estimation. Because when we do the point estimation of some population parameters, actually we have different choice. For example, if we want to do the point estimation of a population mean, there are two ways to do it. One is use the sample mean to guess the mean of our population. The other is use the sample median to guess the mean of our population. So both is actually a acceptable point estimator. However, we want to know which one is better. So for this, the good way is we should compute the difference between the mean or the expected value of our estimator to the value of our point population parameters. So here, this means if this expected value of our estimator is equal the value of our population parameters, then we can say this estimator is an unbiased estimator. However, if this equation is doesn't hold, then that means this distance is not zero. So in this one, we will say the difference between the expected value of our estimator with the population parameters is the base of this point estimator. Okay, so now maybe you think this is okay, so many things, estimator and sigma, some Greek letters, it looks so complicated. Let me use one example to explain this. So let's look at this example. So we want to check use the sample mean as a point estimator of our population mean. So is this a unbiased estimator or a biased estimator? So to check this, it means what we should do is we should compute the mean, or say the expected value of our point estimator. So here our point estimator is our x bar. So this is our point estimator. So to compute this point estimator, what we should do, we should try to compute this mean, plug in the definition of our x bar, the sample mean. So the sample mean is the summation from the 1 to n, assuming we have n observations. So here, this is numerator, and this is divided by our n, which is the number of our observations. So to do this, by this mean, what we know, we have the linearity of our mean, or say expected value. So in other words, here about this mean of ax plus b, so this is equal a mean of x plus b. So here we use this property, so we will have this is equal summation of our from I equal 1 to n of our mean divided by n. So in other words, we can write this as this equation. And then for this one, what's the value for the mean of xi? So for mean of xi, please remember x is all the observations of our, no matter it's random variables. Okay, so here for this one, it means the mean of our xi should equal the mean of our random variable. So that means here for this mean, this actually is equal our mu. the population mean. So now we can rewrite this equation as 1 over n summation from I equal 1 to n times our of our mu. So now for this is n numbers of mu summed together and then divided by n. So in other words, this is 1 over n times mu. So here this 2n will cancel each other. So in other words, our final answer is mu, which is our population mean. So now look at the beginning, the left-hand side of our equation. We have this is the mean of our sample mean. And then the end of this calculation, we get the population mean. So in other words, the mean of our estimator is equal our original population. So that means our sample mean X bar is a unbiased estimator of our population mean. Okay, so this is how to check the 1 point estimator is a bias or unbiased. Okay, so let me give you one question. So the question is, let me ask if this mean is an unbiased estimator, then how about the median? So if we use a sample median to estimation or do the point estimation of our population mean, so is the sample median is a biased or unbiased estimator of our population mean. Okay, so here about this, actually what we do is we compute the mean of our estimator. So then the next question is, what is the variance of 1 point estimator? So about this one, we also want to say when we compute the variance of a point estimator. So what means a good point estimator? So that means this variance is a minimum variance among all of the point estimator. So about this, we call this as a minimum variance unbiased estimator. So we denote this by the notation MVUE. So if we say this is an MVUE of 1 population parameters, this means this estimator should be first unbiased and also should with the minimum variance. So here the lucky thing is the MVUE of a population mean is also the X bar, our sample mean. Okay, so this is one example. And then maybe you will ask what is a standard deviation of one estimator. Then this is very similar for our variance of a sample or a variance of random variable. The standard deviation is here we call this as a standard error. So the standard error actually is a standard deviation of an estimator, and this is just the square root of the variance of the estimator. So we will denote this by sigma sub our estimator. So this is a capital theta with height. Okay, so then this is a standard error of our estimator. And then if we want to estimate, do the point estimation of this standard error, so what will that? So that means maybe this is a little complicated, but like for the literally it feels confusing. But this is for the notation, this is just use another height above our sigma. So all of the height here symbol means this is estimator. So this height above our sigma means this is an estimator of our sigma. So this is estimator of our standard error. And what is the standard error about? This is a standard error of our sigma height. So a theta height, okay, like this. Okay, so this is what's the meaning for an estimated standard error. So now let me use an example to explain this. So let us look at this example. So here we have a population follows a normal random variable, so a normal distribution. So this population is a normal distribution with a mu as its a sample mean and sigma square as denoted as its variance, sample variance, population variance. And then here we have a sample which have n observations, and we denote these samples use the little letters as x sub I. And then what is the estimator we interested? The estimator is the sample mean. So this is our estimator. So in the question, they ask us what is the variance, standard error, estimated standard error, and the distribution of this estimator. Okay, so to do this, what we should do is, the first thing is about the variance of this estimator. So it means we want to compute the variance of this x bar. So to compute this, we need to plug in the equation of this variance inside this of this x bar. So then, similar to compute the mean of this x bar sample mean, what we should do is we should also use the linearity of our variance. So that means here what we will have the answer of this is variance of xr, variance of xi summation I equal 1 to n, and the denominator is n squared. And then by plugging the value of our variance of this xi, this is equal sigma square, right? So about our population's variance. So in other words, now by this computing, we will get this is equal variance sigma square over n. Okay, so this is the variance of our sample mean. Okay, and then the next thing is how to compute the standard error. So standard error, we can denote this by sigma sub x bar. So this is equal to the square root of our variance of this estimator. So in other words, this is a square root of our sigma square over n. So we can denote this answer as sigma over square root of n. So this is our standard error of our estimator x bar. So then the next thing is what is the estimated standard error of our x bar. So now if you look at the standard error of our questions of our x bar. So here there is actually only two values. One is about sigma and the other is n. So in this question about the sample, because sample is something we know, right? When we do some survey, we always know, okay, how many people we select to answer the survey. What we don't know the population. If we want to know like the average salary of all people in one country, we don't know this, so that's why we want to do the survey. And because we don't know like this thing, it means we have no idea of the information for the population. In other words, in generally, we don't know the value of this sigma, because sigma is our population variance. It's something about our population, and in general, it means we don't know the information of our population. So when we don't know this, but we still want to guess the standard error, like the value of sigma over square root of n. The method we do this is we can guess the value of this sigma. So to guess the value of one population parameters. That means we want to do the statistical inference, or in other words, we want to do the point estimation of this sigma. So to guess the sample standard deviation, very straightforward is if we want to guess the population standard deviation, we will use the sample standard deviation to guess it. So the sample standard deviation, generally we denote this by S. So then by this, so to do this, it means we will do the estimated estimated of our standard error of our x bar. So this is equal our S over square root of n. Okay, so here for this one, sometimes they also use the SE to do this. So this is estimated error of our value x bar. Okay, so this is what is the estimated standard error of one estimator. So after this standard error and estimated standard error, let me introduce one more error. So this is our mean squared error. So what is a mean squared error? So we denote this by MSE. So actually this is a mean of our square error. So here, what is this square? This is the difference between our estimator of our parameter. So this is actually read by equation. This is equal mean of the square of the difference between our estimator and the parameter theta. So then by some calculation, that's what we do to compute a variance, right? What we can do is we can also compute this square out, and then this will become an equation of two parts. So here, this will become the variance of our estimator and plus the base. So the base is about our unbiased estimator. So at the beginning of this video. So if you already found out what is this, please go back to look at the beginning of this video. So this is the definition for our mean square error. So if one estimator is an unbiased estimator, so what's the value of this mean square error? So here this means this will just equal the variance of this estimator, because unbiased estimator means this bias rate equals 0, right? So that's why the second term in the previous equation will equal 0. Okay, and then the last thing I want to talk about is what is the relative efficiency of two estimator. So previous we always say we have so many errors, and how we can say if we have two estimator, which one is better. We say the unbiased estimator is better, and the minimum variance unbiased estimator is better. And then if we have two estimators, then how we can compare them in general, like both of them are not a biased estimator and both of them are not the minimum variance, but we still want to compare them. So how we should do it? So to do this, we should compute the efficiency of these two estimator. So this is computed by the dividend between two MSE. So this is we use the mean square error of the first estimator to divide it by the mean square error of the second estimator. So of course, if this value is smaller than 1, so in other words, what we have is the numerator is smaller than denominator. So that means here the numerator is better. So here we call this numerator, this estimator 1 is more efficient. Okay, so because their square mean square error is smaller, so the error smaller is always better. So when the value of this factor is smaller than 1, that means we have the numerator is smaller. And the opposite, if this value is greater than 1, then that means now the numerator is larger. In other words, the denominator is smaller. So that means the mean square error of the second estimator is smaller. So that means this one is better, and we call this second estimator is more efficient. Okay, so this is about how to compare two estimators if both of them are not unbiased and both of them are not like the minimum variance one. Okay, so now when we call what is the optimal estimator. So the optimal estimator generally is an estimator with the smallest MSE. So in general, if we can find someone with a smallest MSE is a mean square error, we call this is an optimal one. Okay, so this is what I want to talk about some property of point estimator and how we can, when we have several estimator of one population parameters, how we can check which one is better. So now this video, I know there are so many terminologies, so maybe you will need time to read, to look at this video again and again to remember all of them. So in next videos, I will start to talk about the very important theorem in the statistic, the central limited theorem, and how we can decide the sampling distribution. So please subscribe this channel and see you in next video.